Welcome to our tutorial on creating nice-looking brain data visualizations using brainTrawler. We can interact with brain visualizations in many brainTrawler pages. For now, let's navigate to the Network Query tab of the human brain. Here, you can see a 3D and 2D visualization of our template brain. In 3D, we currently show the silhouette of the brain. You can also choose from the options Hologram and DVR in the Style selection menu on the upper left. The hologram style highlights the sulci and gyri of the brain, while DVR style closely resembles an MRI image. There are further customization options you can apply to the 3D view by clicking on the settings symbol on the upper right. You can navigate between different 2D slice images by using the scroll bar below. The outline of currently open parcellation regions are shown in each slice. You can change the views shown in brainTrawler in the Layout drop-down menu. For example, the single 3D view only shows the 3D renderer. This also includes 2D slice images in different orientations. There is also the option of using a 2x2 layout, which shows a 3D visualization plus 3 linked slice visualizations. The yellow lines indicate the current center point in the slice views and allow pinpointing specific locations precisely. Let's return to our standard view. We can access additional visualization settings by clicking the settings symbol in the right. Here, we can toggle the bounding box of our 3D template image and also change the background to white in 3D. Now, let's also have a look at creating nice visualizations of data. For this, we can select some query region and run a network query by clicking Target Query. The resulting image will be shown in 3D and 2D. Remove the target region again to get a clearer view of the rendering. Currently, it is hard to see structure in the connectivity visualization in 3D. Let's change that. First, we need to look up the name of this image, which can be found in the workspace on the left. Now, open the Viewer Items sidebar on the right and find the corresponding entry. By clicking on the color tile, you can access the Appearance control menu. Here, we can select the color, contrast, brightness and transparency of objects in our renderers. Let's pick another color and then increase the transparency to obtain a clearer view of the connectivity structure. You can also vary brightness and contrast to further enhance and customize your visualization. Now we can clearly see that the center of the brain is the most highly connected to our query region. Let's tune brightness and contrast a bit more to single out only the regions with the highest connectivity. You can perform these customizations with all image data in brainTrawler. Contrast and brightness adaptations also affect the 2D slice visualization. With network data especially, there is another cool feature you can use. You can overlay a node link diagram over the 3D and 2D renderer by ticking the checkbox, Show Connectivity as Graph, in the region profile. Here, each sphere corresponds to a brain region that is currently open in the parcellation, and the color of the lines between spheres denotes connectivity strength. You can add the brain region short names as labels to the visualization via the Settings menu. The hierarchy level of the visible brain regions can be adapted dynamically by changing the open regions in the parcellation browser on the left. If we open a region, such as the frontal lobe, we will see all of its child regions in the node link diagram. You can also open the current visualization into full screen mode on the upper left. The visualization settings contain several settings that are specific to this node link diagram. For example, you can customize the font size of the labels, or select curved connections to produce a more flashy look for the connectivity visualization. For curved connectivity, the visualization is recalculated every time you adjust your viewing position. Now, you can use brainTrawler to create fancy-looking visualizations on your own. You can find additional information on the brainTrawler help page. Thanks for watching.